Air pollution is one of the major causes contributing to the destruction of our environment. Some of the major causes of this are waste and gases emitted by factories and the internal combustion engine. However destructive though these may be, they are an essential part of our daily lives. Once environmental deterioration has set in, the necessary measures to completely restore nature back to its original condition can be both costly and time-consuming. Therefore, preventative measures must be taken right from the outset in order to prevent such damage to the environment. Japan's history of air pollution, which dates back to just 1867, is a relatively short one. After the Second World War, the number of large-scale manufacturing industries, in particular on the Pacific coast, increased rapidly as economic growth in Japan began to take off. In 1959, the city of Yokkaichi, promoting Japan's petrochemical industry policy, was at the forefront. In a relatively small area could be found petroleum refineries, petrochemistries, and thermal power generation plants. It was also the location of Japan's first petrochemical complex. This petrochemical complex had a huge manufacturing capacity which had never been seen in Japan before. However, due to this plant's operation, the problem of pollution became an issue. The sudden growth in the number of asthma patients was one of the problems resulting from the air pollution, which was rapidly becoming a major threat to the health of the general public. In 1962, as Japan entered a period of rapid economic growth, the first law concerning air pollution, the Smoke and Soot Regulation Law, was enacted. This law regulated emission concentration in the areas where noxious gases were being increasingly emitted into the atmosphere. In 1967, the Basic Law for Environmental Pollution Control was established. Since then, various laws regulating any further air pollution situations have come into effect. Of those laws, in 1968, the nationwide Air Pollution Control Law, which included a ground-level concentration regulation known as the K-value regulation, was made in order to improve existing regulations regarding the concentration of emitted sulfur oxides. Until 1976, the K-value regulation had been revised 7 times. In 1972, the Nature Conservation Law was passed. Then, in 1974, the Air Pollution Control Law was reformed entirely. However, with Japan still in a period of economic growth, the amount of emitted sulfur oxides continued to increase, which gave cause to growing pollution problems across the country. Furthermore, new problems such as photochemical smog and cadmium contamination were surfacing, which had to be addressed. One major part of this new law was total emission control. In 1993, the Environmental Basic Law was enacted. Existing laws, broadly based on the problems of the day, were clearly insufficient. The Environmental Basic Law takes into account the economy and modern lifestyles with an international viewpoint, plans, and carries out environmental preservation. Today, there are environmental problems such as the growth in pollution resulting from city lifestyles, the growth in the volume of waste disposal, the problem of global warming, and so on. Taking a global perspective, there are many problems which need to be directly addressed, such as global warming, depletion of the ozone layer, marine pollution, and extinction of wildlife. And closer to home, the decrease in nature within cities combined with the depopulation of many rural areas has led to a decline in levels of farmland and forest preservation. Right now, campaigns to increase the general public's awareness of the environment are increasing. The aim is to create a society in harmony with nature. When operation started at this complex, sulfur oxides, nitrogen oxides, soot, and dust were being emitted. In particular, the sulfur oxides was found to be one of the main causes of bronchial asthma. Therefore, countermeasures were taken. In 1972, the Mie Prefecture Environmental Pollution Analysis Project team was set up to analyze sulfur oxides pollution. Based on the result of their simulation on the dispersion of atmospheric pollution, total emission control on sulfur oxides came into effect. As existing emission controls were found to be ineffective in improving or maintaining areas which had a high concentration of pollution sources, total emission control was implemented in order to make tighter rules governing the total pollution emission from each factory as well as individual source. All factories in Mie Prefecture complied with the Mie Prefecture Pollution Control Ordinance. Therefore, swift, positive action towards the prevention of pollution, such as fuel oil desulfurization and flue gas desulfurization, was undertaken. 5 years later, in 1977, in spite of the total amount of fuel consumption around the Yokkaichi region remaining almost unchanged at an annual 4 million tons, the amount of emitted sulfur oxides decreased to 1/10, compared to the largest amount on the record. The problem of sulfur oxides pollution was at last beginning to abate. The success of total emission control in Mie Prefecture had a great influence all over Japan. In 1974, a nationwide total emission control on sulfur oxides emitted from factory was introduced. Since then, rapid improvements have been made in reducing air pollution caused by factory emission. Also, total emission control on nitrogen oxides emitted from fixed sources, such as factories and so on, have resulted in pollution reduction. However, since 1986, the amount of nitrogen oxides, mainly in the cities, have continued to worsen. One contributing factor to that worsening has been the increasing use of trucks instead of railways in the goods distribution service. The number of diesel trucks being used has dramatically increased. The removal of nitrogen oxides emitted by diesel engines compared to petrol engines is an extremely difficult technological task. For that reason, the major cause of air pollution today in Japan is exhaust gas from the vehicle, in particular nitrogen oxides being emitted from diesel engines instead of sulfur oxides emitted from factories. The sources of air pollution can be categorized into fixed sources and mobile sources. As pollution sources vary, the content and methods of anti-pollution measures vary as well. Typical examples of fixed pollution sources are thermal power stations, petroleum refineries, petrochemical plants, steel plants, cement plants, metal smelting plants, and refuse incinerators. Most fixed sources emit sulfur oxides, nitrogen oxides, and particles of soot and dust. And examples of mobile sources include gasoline or diesel engine vehicles, ships, aircrafts, and so on. Automobile exhaust gas includes nitrogen oxides, carbon monoxide, hydrocarbon, other suspended particulate matter, and so on. Now, let's take a look at some of the factors resulting in the various types of pollution. Fuels, such as oil and gas, which contain sulfur, are burned in boilers or heating furnaces. Then, the sulfur is oxidized and becomes sulfur dioxide. There are two main causes for the generation of nitrogen oxides. One is the presence of both nitrogen and oxygen found in the air at the time of combustion. These react at the high temperatures to emit nitrogen oxides, called thermal nitrogen oxides. The second cause is a result of the various nitrogen compounds in the fuel oxidized during combustion, which generates nitrogen oxides, called fuel nitrogen oxides. Soot and dust refers to the ash and unburned carbon residue from the fuel after combustion. Carbon monoxide is a result of incomplete combustion. Oxidants are the result of the photochemical reaction, hydrocarbons and nitrogen oxides sparked off by the sun's rays in the atmosphere. They are the major cause of photochemical smog. Flue gas desulfurization is one method being employed to reduce or ultimately remove sulfur oxides in the flue gas. There are two methods of flue gas desulfurization: wet system and dry system. Of those two, the most commonly used in Japan today is the wet system. The wet system involves the cleaning and removal of sulfur oxides from smoke by using absorption liquid. Good stable levels of sulfur reduction against load fluctuation have been accomplished using this tried and tested method. The nitrogen oxides, such as nitrogen monoxide and nitrogen dioxide, are the result of fuel combustion. Emissions of nitrogen monoxide enter the atmosphere, where they gradually react and transform into nitrogen dioxide. The process of eliminating nitrogen oxides involves technological methods to decrease the generation of nitrogen oxides and flue gas denitrification techniques. The technology used to reduce the generation of nitrogen oxides include improved and stricter furnace combustion techniques in order to lower the amount of the generation of nitrogen oxides. The basic measures taken in order to decrease the generation of nitrogen oxides are use of fuels which contain low quantities of nitrogen, lowering of oxygen density in combustion environments, shortening of the residence time in which combusted gases remain in a high-temperature environment, lowering the combustion temperature and in particular the removal of concentrated areas of high temperatures. By taking these measures, scheduling the reduction of nitrogen oxides can be carried out. Techniques presently being employed to reduce the generation of nitrogen oxides include a two-stage combustion method, the use of burners for low-level nitrogen oxides, and the exhaust gas recirculation. The two-stage combustion method involves air for combustion being fed in two stages to carry out complete combustion. This technique has a positive effect on both thermal nitrogen oxides and fuel nitrogen oxides. When using burners for low-level nitrogen oxides, the size of equipment is of less importance. Therefore, as equipment costs can be relatively low, this is the method most commonly being used today. Exhaust gas recirculation is the method to burn a part of recycled gas in large boilers. This is used to great effect with thermal nitrogen oxides. The most advanced flue gas denitrification technique is selective catalytic reduction. This technique is used to reduce nitrogen oxides to nitrogen by using a catalyst. Denitrification in the furnace is called a three-stage combustion method. Fuel is supplied in two stages. In the second stage, hydrocarbon reacts with nitrogen oxides, resulting in reduction. The third stage involves the adding of air for complete combustion. Electrostatic precipitation is the main method used in the removal of any soot and dust generated. This method, electrostatic precipitation, first applies a direct current high voltage which produces corona quenching. Particles of dust present in the gas are then electrically charged. The electrically charged particles then pass through an electrical field which causes them to separate from the gas. Measures being taken against other pollution include removal and reduction of carbon monoxide and hydrocarbon. At present, the main causes of air pollution are nitrogen dioxide, sulfur oxides, carbon monoxide, photochemical oxidants, suspended particulate matter, and acid rain. Let's take a look at the present situation concerning each of these problems. The biggest contribution to nitrogen oxides pollution in Japan comes from the vehicles, and in particular, the diesel vehicles. The laws restricting levels of exhaust gas from the diesel for various technical reasons are not stringent enough. In Japan today, great improvements have been made in combating concentrations of sulfur oxides in the air. Environmental standards goals have been achieved with a 99.7% success rate. The major cause of carbon monoxide is vehicles, in particular the gasoline vehicles. In Japan, as measures were taken early in order to control exhaust gas, positive results in reduction of carbon monoxide have been achieved. Photochemical oxidants are the strong oxidizing substances which result from photochemical reaction in the atmosphere among nitrogen oxides, hydrocarbon, and so forth by strong ultraviolet rays. Atmospheric conditions have a big influence on the generation of photochemical oxidants. However, warning information has recently become less. Levels of suspended particulate matter have been unchanged for a long time. The success rate for the environmental standard of this pollution is about 50%. Recently, however, an increase can be seen in the percentage of carbon particles emitted from diesel engine combustion and microparticles generated from sulfuric acid and nitric acid. Acid rain with a pH value of less than 5.6 was first recognized as an environmental problem in 1973 when it was the cause of damage in the area between Suruga Bay and Yamanashi Prefecture. Since then, every region in Japan has observed some kind of damage caused by acid rain. In particular, during the winter, acid substances such as sulfur ions can be found around areas on the Japan seaside of the country. In some areas, the problem is acid substances which come with seasonal winds blowing in from the Asian continent. Acid rain can affect places from a great distance away and is a problem which can be observed on a worldwide scale. Today, This is a big problem in Europe, where acid rain can be found in Western European countries such as England and Germany, and Central European countries such as the Czech Republic and Poland, and it's a problem which is likely to become more widespread in the future. Air pollution varies from region to region according to that area's pollution source or natural conditions such as topography. However, it has been proven that positive action taken at the source of pollution can be effective in removing the problem. Air pollution is not just a regional, but worldwide problem as well, and it is a problem which needs to be addressed seriously. In order to control pollutants such as sulfur oxides, nitrogen oxides, and carbon dioxide as a result of the combustion of fossil fuels, energy saving is essential. This can be linked also to the preservation of natural resources. As the supply of fossil fuels is limited, alternative energy sources such as solar energy, wind power, geothermal heat, hydraulic power, and so on are being researched and developed. It is said that the amount of solar energy in the form of sun rays is equivalent to 10,000 times the amount of energy being used by the world's population. As solar energy is clean, pollution-free, and inexhaustible, it is attracting a great deal of attention. It is possible to use both solar heat and rays. Solar batteries, which make use of solar rays already, have a variety of daily roles, such as domestic power sources, vehicles, lighthouses, satellites, street lighting, road signs, leisure equipment, and so on. Solar heat is used for power generation, water heater, etc. Further proof of the technological developments in the field of solar energy. As we realize the importance of preserving our planet, we continue in our efforts to overcome air pollution, while at the same time progressing towards the development of clean energy.